We sure hit on a nice day for a walk today. Look at how pretty it is.
Yeah. I have a question. Why is the sky blue?
Why is the sky blue? It's to make us happy. It makes us happy, doesn't it?
Yeah, but I'm not sure that's the exact scientific reason for why the sky is this tint of blue.
You don't believe that? Well, how about this? How about if I tell you that there's little tiny sky fairies that come out every day, and they just come out, they're tiny little ones, they've got tiny little paintbrushes, and they all go around the sky, and before the sun goes up, they paint it all blue, so it's all blue for us when we wake up.
Is there a little more scientific reason?
You don't like that one? Isn't it that nice story?
Yeah, but I'm not sure it's exact reason why it's blue.
You don't believe it, eh? Okay. Did you believe in fairies?
Kind of.
Yeah, well, so some people might like that explanation. But here's a more scientific one. You know how water refracts light? You can see a rainbow in the sky. It separates the different colors of light out, just like a prism. You've played with a prism, right? So when the water droplets in the air separate out the colors, we end up with blue.
Yeah, but then if that happened, all our sky would be orangey blue and different colors of the rainbow.
You think we should have rainbows all the time? Well, that's pretty smart, because actually that's not how it works either. It's just an explanation that some people say. I was looking it up, and it really has to do with the nitrogen and the oxygen molecules in the sky, in the air, because those are tiny molecules, and the different wavelengths of light coming in are the different colors of different lengths, so that the blue light is tiny little wavelengths, and the red light is big, long ones. So we've got these tiny molecules, and the big wavelengths go right past them, but the little ones, they get trapped and get shoved one way, trapped and shoved another way, and so the blue light is scattered, and some of the light still comes through because we get blue color, blue wavelengths on the ground, but enough of it gets scattered up there that when we look, it looks blue.
Yeah, and I guess the red ones just go way over the trap of light, way over, and then they kind of miss it. But since there's, I think, more of the little ones, a lot of the little ones that are all over the place more, not in a long kind of a loopy line, but lots of them going everywhere, then they can expand into this bluish white tint.
Yeah, it's not really necessarily that there's more of the blue ones, it's just the size of them that matters. There's still enough coming through, as I mentioned, but we know there's some situations where you get a red sky.
Yeah, when there was a bigger of the red beams, but why is that only either in the morning or the night?
Aha! Well, you know the Earth is round, and so when the sun's coming up from the top, it's going straight, and when it's coming at night, it's coming sideways, and it's going through a whole lot of atmosphere. And there's water droplets in the air after all, and you only get the red sunset and sunrise when there's clouds, and it's red. I mean, there's water vapor in the air, because the big water droplets do the same thing to the red light that the tiny molecules of nitrogen do to the red. So they scatter the red instead. And so we get a nice red sunset. Does that make sense?
Getting there.
Okay, we'll talk about it again. Let's go. Oh, no, it's...